So motors and engines like to run fast. If you think about a car, it idles around about 1,000, 1,500 RPM, something like that. And it's probably working at its most efficient in the region of sort of 2,500 RPM. And the same is true of electric motors. But of course, the wheels on your car don't turn anywhere near that quickly. They're going from tens of RPM to hundreds of RPM at the most. So there's a huge mismatch between what the engine is delivering and what the wheels actually need, or whatever you're going to do with that power source. You might think, well, just bung less power in there and turn it slower. And this is certainly something that the European motorcycle market thought of. But the Japanese came along with a completely different vision, of course, and they went for short piston stroke, high RPM engines with a gearbox. The Europeans had gone with long piston stroke, slow revving engines, and with not so much in the way of gears. And of course, they learned a sorry tale, and the European motorcycle market is more or less dead, and the Japanese bloomed because engines like to operate in that speed range, and they're more efficient, last longer and cheaper and so on. And so it's an important issue when it comes to turning an engine or a motor output into a useful output. And lots of people have been working on that. What I want to show you is this. It's actually called the Perpetual Wedge by James White, and it was invented in 1786. Let's have a closer look at it. Here's my Tinkercad drawing of it. And actually, this isn't the original. It's very close to the original. This is just large to be a demonstration model. The original looked like this, and that's what appears in James White's patent. But if we go back to the Tinkercad drawing, what we can see are two gears. The bottom gear is 100 teeth, and the top gear has a 99 tooth and a slight eccentric. Because the mismatch is so slight, it can be difficult to see in smaller versions. In this one, if we look closely, we can see that the teeth near to the roller are aligned. The teeth furthest from the roller are not aligned. As that roller gear goes round and round, it will pull the teeth into alignment. And for one full revolution, that top gear will turn only one tooth. Now, it's only essentially 5 parts. There's the base plate, and on top of that goes the turn handle, and that needs to be free to spin. On top of that goes the 100-tooth gear, and that gets fixed to the centre spindle so that the base and the 100-tooth are fixed in relation to the turn handle. Then our 99-tooth gear goes on, and we align the teeth. Just keep twisting it because it's an eccentric, remember, until teeth are aligned. And when their teeth are aligned, that goes on, which is actually just a roller. So this roller doesn't take part in the gear ratios. All it does is move around, pulling the teeth, aligning to each other. And you can see they're unaligned here. As they align, this for one full revolution will align that tooth by one tooth movement only. So that 100-tooth gear is only glued in place. It's just so that the handle and the roller gear are free to turn, and there's a clip that's gone on top of the roller gear. This one then just slots on. It doesn't get glued, and you twist it round until it engages with the roller. And then I've put a clip on top to hold that in place. Now I've put a little dot right there, and as I move this handle round, what you'll see is that dot moving, but quite slowly. That's awesome. It's like magic. So in this form, you might think, well, what use is that? But actually, it's tremendously useful because, of course, you get a concurrent increase in torque when you decrease speed to that much. And this is 100 to 1. And this form was used in things like cranes and pulleys and lifts and that sort of thing. So if I apply 1 kilogram of force here, what I'll get is 100 kilograms of force there. So instead of having teams of men lifting things onto ships, you could stick this in a crane and have one man doing the job. So in 1786, this took the world by storm. White got loads of prizes. I think Napoleon gave him a prize, but it was a hugely important invention. Now these days, of course, that particular form perhaps isn't so useful, but that concept of having the one tooth difference and forcing it to go around like that is something that we can develop from that basic idea. And here is a more modern form. Instead of having it as 2 spur gears with a 1-tooth difference, what we've got are 2 ring gears with a 1-tooth difference. And that roller that drives on the side there it is, we can put that in the centre on a spindle, which is exactly what that is. So we put that in the centre. Then all we have to do is join this to this and we'll get the same effect, because the size of the roller has no impact at all. So if we put a single gear in there to join those 2 up, it'll do the same job. Of course, we want to spread the load, because having 1 single gear will have quite a lot of load on there. So we can arrange 3 of them in the same way that we would arrange a planet gear. Once we've done that, we can pop our gear on that has 1 tooth less onto there. There we go. And now when we turn this handle, you might notice that this one is turning very much slower than the spindle that we're turning here. These, of course, are demonstration models, so they're a little big and chunky. I mean, chunky's not bad if you happen to put it on a crane, but you can make these very compact and very small indeed to get those incredible gear ratios. And the importance of a gear ratio like that, you get an awful lot of torque. It moves much more slowly, but that's what you want very often. And this flatter pancake form, where we've got the 2 ring gears as split into 2, where that's the drive axle, that's the output axle, of course makes for a very compact and useful gearing system. So, the perpetual wedge, invented in 1786 by James White, can be incredibly useful if you look at it a slightly different way. Anyway, I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.